Imagine, you sit in the spaceship seat. The target is Venus. The closest planet to us. The one that the ancients called the star of love and beauty. The one that shines brightest in the evening sky. But once you enter its atmosphere, everything will change forever. Because Venus is not just hell. It's a place that won't let go. Let's figure out why not a single person who sets foot on the surface of Venus will return home. Never. The first thing that greets you is clouds. Not white, fluffy, like on Earth. Yellow-orange, dense, endless. And they consist of sulfuric acid. The concentration is up to 98%. It's not a light rain. It is an acidic mist that slowly but inexorably corrodes everything it touches. Titanium, gold, Teflon, and even some superalloys begin to break down after just tens of minutes. But clouds are just flowers. You go 50 to 60 kilometers down, and you get into the lower atmosphere. There is no acid rain here anymore, because the temperature is too high. The droplets simply evaporate back into the gas. And the temperature is already plus 200. Plus 300 degrees Celsius. Your spacesuit starts to heat up. Ordinary materials melt. The rubber is leaking. The plastic softens. Even the best modern thermal protective coatings, which have withstood the return from Earth orbit, begin to degrade in minutes here. But it's still not the surface. When you finally break through the last clouds, you are greeted by 465 to 475 degrees Celsius. This is the temperature of a hot oven for self-cleaning. This is the temperature at which lead flows like water. This is the temperature at which tin and zinc melt, and aluminum is already soft, like plasticine. And now the worst part. Pressure. 92 to 93 terrestrial atmospheres. Imagine, you are lowered to the bottom of the ocean to a depth of 900 meters. Only there is cold water. And here it's red, hot carbon dioxide, which behaves almost like a liquid. Your body will just flatten out. The human body can withstand 3 to 4 atmospheres in a pressure chamber for a short time. Professional divers descended to 7 to 10 atm with a helium mixture. But 92 atmospheres? It's an instant death. Bones break like dry twigs. The chest collapses. The lungs turn into a cake. Even if you miraculously survive the first few seconds, you won't be able to breathe. The atmosphere is 96.5% carbon dioxide. Oxygen is almost zero. But let's say, a fantastic scenario. You are wearing a heavy-duty space suit made of 22nd century materials. It can withstand pressure and temperature. You have oxygen for 30 minutes. What's next? You need to take off. On Earth, a rocket takes off because the atmosphere is thin and gravity is 1g. On Venus, it's a different matter. The first problem is that the atmosphere is too dense. To ascend, you need to accelerate to the second cosmic velocity of is almost equal to 10.4 kilometers per second, almost like on Earth. But in such a dense environment, the resistance is enormous. Your rocket will spend 90% of its fuel just to break through the atmosphere. The second problem is that heat and pressure destroy engines. Liquid-fueled rocket engines use turbopumps that spin at tens of thousands of revolutions. At plus 460 degrees Celsius, the bearings melt in seconds. Fuel. Kerosene, methane, hydrogen, everything decomposes or boils long before ignition. Solid fuel boosters. They burn too fast and uncontrollably in this heat. Nuclear engines will melt already. The only theoretical idea for today is an atmospheric SEO rocket, a carbon monoxide engine produced from the local atmosphere. But even in this case, you first need to get fuel, cool it, assemble the rocket, on the surface, where everything melts and crushes. And now the scariest part. Even if you miraculously take off, you need to break through those acid clouds back up. And every gram of your ship is already covered with a layer of sulfuric acid. Every seam is corroded. Every valve is leaking. The chance of reaching orbit is vanishingly small. And there's another surprise waiting for you in orbit. Venus has no magnetic field. The solar wind blows directly into the atmosphere. But the main thing is that there is no protection from radiation during the long flight home. But these are small things. Because the truth is different. No one is designing return ships from Venus, because it is impossible at the current level of technology. And in the foreseeable future, too. The Soviet Venera 13 and Venera 14 stayed on the surface for 127 and 57 minutes. It was an absolute record. They were made of titanium, cooled with Freon, and the electronics were made in Germany. And they died anyway. Modern NASA concepts, for example, sample return projects, involve either sampling only from the atmosphere, or very clever schemes where the lander does not land for a long time at all, but only touches the surface for seconds. But a man, with his fragile body, the need for oxygen, food, cooling. Impossible. Venus is a trap planet. One-way ticket. She is beautiful from the ground. It's deadly up close. And that's why. Anyone who does decide to set foot on its surface will stay there forever.